Okay, hello everyone, good morning. Applause to you. You managed to wake up very early. So I'm going to talk about security from the point of view of testing engineers, and big disclaimer, I am not a security expert. So feel free to double check and to validate everything that I say. Don't trust me because I'm, just some random guy on the internet. I hope you have seen this picture floating around in the internet. So this is how we are supposed to do testing and development nowadays. Hopefully, most of the companies that we work in are doing this already. And with the blue, we have all the development activities. And with green, we have all the testing activities. And they say, you should be testing everywhere along the way and contributing a little bit to the quality of the product. However, this picture doesn't say anything about security. And what I say is we can do a little bit of security testing everywhere just to add a pinch of improvement in every single step of the way. And this will go a long way at securing our products. Maybe you have also seen this picture, which is what they call shift left, shift right in QA responsibilities. So we get moved to a little bit to the development part of the stack, a little bit to the operations part of the stack. We testers are put outside of our comfort zone to deal with different types of tasks, different types of tooling. And again, this doesn't say anything about security. The thing is, we can also, use these additional roles, these additional tasks to help with security a little bit more. So I'm going to talk about all of these things. I'm going to give you examples how we approach the application under test itself. Main example is our own open source project, which is called KVT CMS. Then going to talk a little bit about the software dependency stack and why this is important, like what we realized working on this project. Moving on to test infrastructure, and at the end I just want to leave you with an idea that there's still a lot more that can be done. And we as testers are in a very good position to contribute in all of these areas, even more areas outside of this presentation, just by thinking about them, applying what we already know about testing. So some time ago, like about 2 years ago, we have had this bug in the application, exposing user credentials. So we have an API layer, and somebody a long time ago before us decided that it's a good idea to log all the API calls in the database for debugging, for auditing purposes. And what they do is take this at the bottom. So they log the current request, the API method name, and all the parameters. And lo and behold, we have two methods which are called authentication login and user.update. The first parameter is the username, and the second one is the password. So this thing goes into the database. So we fixed this bug, obviously, and we started thinking, okay, how do we test this? So how do we model our testing so that we can discover these problems, we can fix them in the future, or if a developer tries to introduce something like that in the future, we don't accept it. And analyzing software under test is what we do as our daily job. So this is just a few properties which are related to security. In every modern application, you have pretty much all of these. So actors in the system who does what? Like you have users, you have groups, you can have organizations. In any modern framework, this is designed around some kind of permissioning system. So this is what controls the level of access. And then on top of that, you can have a multi-tenant architecture as well, which is, which groups of people or which tenant is allowed access to some kind of resources. And there are different ways to implement this. You have interaction points in the application where people interact with the system. So API handlers, HTTP handlers, serving responses back to the browser, user interface, which is usually around some kind of templating language, database, file system, and so on. And in all of these places, you need to be thinking, okay, does the current user, the current actor, have access to this? What kind of permissions governs the access to this resource, and so on. And it can be the case that you have your API handlers set up correctly, and you have your backend code that serves requests to the browsers not set up correctly, or the other way around. These things happen. Then you have the standard actions that can be done in a system, create, update, delete objects. And I want you to pay attention to the last one, which is modify related records, or if you have many-to-many relationship. In a lot of the web frameworks that exist today, when you have two tables and they have a many-to-many relationship between the two of them, the results are stored in a third table. And this is usually a different permission setting. So it is possible in practice to modify the relationship between two objects without being able to modify any one of the two objects. So this is yet another thing to pay attention to. And at the end, you have the distribution layer. I'm not going to talk about this. This is how you deliver your product to your customers. You can deliver the same product in many different ways. It can be some installable package that goes on the internet. If you're on Windows, can be setup.exe. If you're on Linux, can be native Linux package. If this is something like a web system, can be Docker image, can be cloud image. And for every single of these vendors, especially the cloud vendors, they have tons of documentation, how you're supposed to be building these images, what's supposed to be in there, what's supposed to not be in there. And in my experience, people don't read this documentation. So a lot of things to test. Here are a few examples. Like all of these were discovered just by thinking around these properties and trying to figure out what is going on in the application. First one was bogus permissions in the API layer. So we have these two functions. They are functioning correctly. Both of them are safeguarded with this permission required decorator. The permission labels inside of the decorator, they are correct. Everything is fine. The problem here is inside of the create function, we have these three lines which have been copy-pasted between the two functions. So depending on the input values, this create function has two different behaviors. And these two different behaviors are supposed to be guarded by two different permission labels, which is not the case in this example. So that's a problem. There are many ways to solve the problem. I prefer ways to delete stuff. Another thing which we've seen a lot of times in our HTML templates. So we have menu options or buttons where the users are supposed to click. And this is again guarded by some sort of permissions in the templates. We had a lot of typos and checking the wrong permissions, copy-paste errors. These are very easy to happen. And initially we were testing let's test the positive scenario with a user who has all the permissions in the system and verify that this button is available and they can click on it. And testing the negative scenario is let's test with a user that doesn't have any sort of permissions in the system and make sure this button is not available. And of course, both of these scenarios were passing. And we learned that when you need to test something around permissions, you need to be very granular. Testing the positive scenario only with the permission that gives you access and nothing else. And when you're testing the negative scenario, apply everything else but the permission that you're supposed to be testing. This is much more better way to do testing. A lot more other errors related to just the similar types of errors in this application, similar type of problems. The first thing that we started doing is invest in customized tooling. So we use a lot of static analysis tools. We started building plugins for them to be able to discover these problematic areas in the application. So we look for bucket functions for API functions that do not have permission required decorator, that do not have correct permission labels, and we try to fix them one by one. And this is a tedious task. It takes a lot of time, but when you start investing in tooling, at least it gives you an idea how bad or how good the situation is. Moving on to more tooling. So when we started investing in custom tooling, we decided, okay, let's look at what is out there available for us. We work with Python primarily, so my examples are from Python tools, but then I have 2 slides with links to a lot more tools available for every different language. So first one is Bandit, that comes from the OpenStack project, a very good tool. And we said, okay, so if these guys are using that, that's a huge project, a lot of developers there, let's give it a try. We run the tool. This is just an example of the types of errors that this tool is supposed to detect. And the idea here is not everybody to be careful, but just give the developers a tool which will tell them you're using some functions which may lead to security vulnerabilities. They may not be a problem in the current case, but we don't know. So just a few examples. The biggest problem that we had is remote code execution. And this is the actual code on the slide. We have these 2 lines in a function. So basically execute everything that comes from the browser and just happily execute it in the namespace of the application. And the second line tries to import some module based on the name coming from the browser, which again can be used for code injection. And we did have somebody on our public demo site some time ago, somebody deleted everything from the database. We don't know whether they exploited this same vulnerability or something else, but this thing happened. So this is what Bandit can help you with. Another thing with these toolings, that they just go through your source code and try to find some patterns which are known to have problems, is hard-coded passwords. This is a good thing to have. However, a lot of the times it will give you false positives which are coming from your test suite. And you need to be careful when you ignore something, or you need to design how you invoke your tools to make sure you don't have a lot of false positives. Otherwise, everybody will start ignoring them. Another interesting pattern that not many people talk about is ignoring exceptions. And this tool, Bandit, it will tell you, if you have try except pass or try except continue pattern, it will tell you you are ignoring exceptions. And there is a separate presentation from Yegor Bugayenko on the topic, a very good one. But the problem here is if you ignore exceptions, you have no idea what is happening in your application. Maybe it's a genuine error, in which case you need to fix the error and make sure the application handle the error condition, or maybe somebody is trying to do something bad to your application. And we've got an example for this. So we apply Bandit. There were a few spots where we were ignoring exceptions, so we just removed the try except blocks, and immediately we get this error logged into our monitoring system, which doesn't look very scary at first. It's a value error. If you manage to read what it says, is we have a string which we try to convert to an integer number and then send a database query at the bottom. And the string is tc number 1, so for test case number 1. We don't know if the user typed in something incorrectly or if the user was very, very clever and tried to masquerade this as an SQL injection attempt. But if we read in the traceback, there is an HTML form which is created from this input data from the browser. It is validated and it is reported as valid, and then we just take all the values and send them to the database as an SQL query. This is what is happening here. So we see this error. It doesn't matter for us if the user just typed in something incorrectly or they try to hack into our system. This is an error in production, so it gets a lot more priority. We fix it immediately. And the way we fix it is make this field validate as an integer in the form. The next time the user tries to do this, they get a nice error message in the browser, and this thing never touches the database. It will exit on the previous line. So this is how not ignoring the exception helps us. Another thing that these tools are able to discover is generally using older hash functions, using random and stuff like that. And they tell you, listen, please don't use these functions or these libraries because they are now considered not so secure. They are considered weak. So let's try to use the latest and greatest. Initially, we were using MD5, and then we switched to SHA1. And after a while, Bandit was updated to report SHA1 as also old and not quite secure. So we switched to SHA256. And then in the same function, Bandit tells us, you are using random, and please don't use random in anything related to cryptography and security because it's a very, very bad idea. And the tools don't know what we were doing, but of course, this is exactly what we were doing. We are using the random function to create something which we call a sort, and then we create something which we call an activation key. And this is in the part of application where when the user registers an account, we send the randomized link to them to validate their email address. So that is the thing that we are trying to do in this function. And all of this is complete nonsense because in every programming language, there are functions, there are modules designed to work with password hashes, with secure tokens and stuff like that. So we don't need to reinvent the wheel, just use whatever is available in the language. And in every language there is something that is available there. So just start using it. And the last thing that this tool was able to discover for us is parsing XML files. So it tells us, listen, in the Python language, the standard module to work with XML files is very insecure. It's not recommended to be used for absolutely anything. And we started looking at this because initially, why is this a problem? Like, why should we care about this? And I have examples like here from the Ruby on Rails project that why you should care. And the truth is, if you are parsing file formats, that is very dangerous. This is basically getting data from the user and either sending this directly to your database or maybe opening up a possibility for code injection. If you're doing this on your own, like to try to implement the algorithm, chances are most of the times you're not doing this correctly. Even if it's an open file format, open standard that is well documented, these things have edge cases. Big projects, big companies, they don't get them correctly on the first try. So if you're using a library to do this for you, make sure it's well tested, make sure it's the latest version. This is what this type of error means. And last but not least, if you have an API layer in your application, maybe you don't need to have import and export functionality for machine readable files. Maybe just an idea. Moving on to another tool that we use, it's called Coverity Scan. This is well known in the software industry. This company has been around for probably 15 to 20 years. It supports many different languages, started with support for C languages, supports now Java, PHP, Python, Ruby, JavaScript, and probably a lot more. What I want you to pay attention here is the graph on the top and this red line, which is pretty much constant over time, and after a while just skyrockets. And the question here is, what did we do as a software team for this graph to go to the sky? Like, what did we mess up? And the answer is we didn't mess up, we just figured out like what everybody else was doing. Developers on your team, what they do is they Google for some library or some framework that will solve a particular class of problem. They install this locally, can be npm install, pip install, whatever install from your language, Maven install. They play with this locally. If it seems to work, if it seems to solve their problem and like they are happy with the usage of this library, git commit, git push, and this goes to production. If you are a startup, for example, and like the most important thing for you is to be fast to market, the time from downloading something from the internet and pushing the same thing to production can be just 2 hours. And there are companies that work like that. So this is very dangerous because you don't know what is happening. You don't pay too much attention into these libraries. It doesn't matter if they're open source or closed source. You just don't evaluate them long enough to figure out if there are problems with them. And I have a few examples. There is this library called Django Attachments. Obviously, it deals with attachment files. They had a bug which could lead to denial of service attack for your application. The problem is when you attach a file and you want to delete it, they save the information about this file in 2 places. One is the actual content on the file system, and the other one is metadata in the database. And the library is deleting the metadata from the database, but not deleting the actual content on disk. So you can upload and delete very small files, and you can fill up the disk space of this application. It will stop working. Or they will pay a lot of money to their storage provider. Next example is this SSH decorator package that is from last year. Apparently that became very popular at some point, and this is a screenshot from Reddit. So somebody posted this, listen guys, this package has a backdoor inside of it and it tries to steal your SSH keys. And not only does it steal your SSH keys, but it sends them here to over non-encrypted HTTP connection. So everyone who is listening on the line, they can also get access to your keys. Double bad. Unfortunately, when I saw this thing on Reddit, the package was taken down from the internet, so we don't know the history. We don't know how this thing happened. If the original author was malicious in the beginning and just nobody paid attention, or if they were very careless and accepted a pull request which added these things. So we don't know what happened. However, in this case, this is from end of November, beginning of December last year. Node.js package, very, very popular. We know what happened. The package was not maintained for a couple of years. The original author moved away to work on something else, but still this thing has millions of downloads on npm.js. And somebody sends them an email, says, listen, I want to help. I see a lot of bugs open, a lot of pull requests open, which can be merged. Obviously, you don't have time to maintain it. Give me access to your package repository, give me access to the GitHub account, and I will merge this for you, release new version. And of course, the original author was a little bit careless. That's his fault. He gave access to the person. When you look at the malicious account, it didn't have real name assigned to the account, didn't have a picture, didn't have any prior history on that GitHub account. So very suspicious, and they gave them full access. What happened in just a few days is the malicious person added some payload in the package along the lines of mining cryptocurrency, push a new version. People see new version, oh, new version that is coming out after 2 years, let's upgrade immediately. Millions of people start upgrading all the time without realizing what is happening. And this thing happens all the time, especially in the Node.js world. Right now, they have their own dedicated team to monitor the new package versions and new updates and try to save people from these things. So this happens all the time. If you think that commercial companies are immune to this, you are wrong. InfluxDB is a for-profit company. They release their client libraries as open source on GitHub. And this is an issue filed by a friend. So they had a pull request which was merged around 5 months ago before the issue was open. No new version of the library, of the package. And inside of the pull request, you have danger comment in the documentation. You have the words SQL injection in the code, and you have the words vulnerability or vulnerabilities in the code. So if like the person that is doing the pull request review before merge, if they see any one of these, like they should immediately know, okay, I need to release a new version of this package when I merge this pull request. And to my knowledge, it's probably been around 7 to 9 months already since this thing happened. There is still no new version, and the latest version that is available is still vulnerable. So this is what it means. Every software has dependency, and relying on dependencies means trusting other people on the internet with your production environment. The screenshot is from our own project. We have around 30 different contributors, which are actual people. We do have a few bots as well. And these 30 people, everything that they did, we checked, and we did code review and merged into our source code base. The entire dependency stack has more than 20,000 contributors. So these are 20,000 people which we have no idea what their level of experience is, who reviewed their code base, how this code base is tested, if these people are malicious or if they are not malicious. So, and to answer my questions, why this graph that I showed you rises is, the reasons is we didn't do anything bad in the application. We started using our tools against the dependency stack as well. So at the bottom, you can barely see this here. These are the errors coming from the application itself, and these are the errors coming from the entire dependency stack. So the top is the Python dependency stack, and the bottom is the Node.js dependency stack. You can see how much more errors the tools report. Not everything, of course, is an actual error. Some things are false positive, some things can be safely ignored, but the point is here is you need a lot of resource, a lot of time to examine everything one by one. And we started using all of our tools against the application itself and against the dependency stack itself. They report so many errors, some of the tools even crash. Moving on to more examples, this is a different project. Written in JavaScript, React.js application, nice looking. So this thing became available last year. Before that, it was available as a separate tool. npm read command if you use JavaScript. So on the day the announcement came out on the internet, we decided, okay, let's run this command against the project and see how it's looking. We run the command, it reports 10 issues, too high severity, both of them coming from jQuery, and we have two different versions of jQuery in the same project. So that is absolutely ridiculous. What you need to do here is, of course, work to upgrade to the latest versions, work to unify all the versions that you are using, so at least you're using only one version, not two separate versions, and this can take time. GitHub also has similar functionality, and this is screenshot from the same project on the same day. GitHub reports everything fine, no problems. NPM audit tells you 10 problems, GitHub tells you 0 problems. So what do we do now? We need a third tool, an arbiter. And there are many, many tools. The one I like is called snyk.io. It's a startup from London, provides this as a software as a service. They support JavaScript and also a few other languages. In my opinion, the JavaScript support is the best, but it can vary. What is good about them, though, is that they have their own security research team. So these guys are able to find problems that the other vendors are not able to find, and they are able to report problems ahead of time. We have seen several times snyk.io reporting problems several days to 1 week before GitHub reports the same problems. So this is important. Lesson here is, don't trust your tools, or don't trust any single one of them. Try to use many tools. So here is a list of just a few tools. On the first link, if you search for static analysis tools or security analyzer, stuff like that, I came up with the first link. There are hundreds of tools for many programming languages. 20 of them have the word security in the title or in the description. So you see how many. And these are only the open source tools. You have a lot more commercial tools as well. There are tools like this thing, Bit, which are based on some theory. There are PhD papers behind them, and we've tried that one in particular. We're not sure if we're stupid enough and don't know how to use it, or we just, I don't know, didn't find the tool useful. There is the OWASP project, and I think later today is yet another presentation talking more about OWASP. I have not tried this one, but I know that it's a good one. It's a very old community focusing only on securing applications and providing tools for finding security vulnerabilities in your applications. There are many, many tools available. So what you need to do is just play around with them, figure out if they work for you, use them for a while. If you don't know what to do with them, or if you think they're not valuable to your team, just take them away and try to find something else. And lucky for our team, we have come to a situation where we can upgrade immediately. So we've slowly upgraded to the latest and greatest versions of all of our dependencies. And now we have these robots which monitor the internet for any new version. If something new is available, they will open pull requests automatically. Tests will run automatically, and you can even go ahead and merge automatically. And there has been this picture floating around recently on the internet that a bot found a vulnerability, another bot fixed it and open pull request, a third bot ran the tests, a fourth bot merged it, and the fifth one celebrated with a GIF picture as a comment. So this thing is now possible. There are services for every programming language out there. We use the PyUp.io is for Python, Greenkeeper is for JavaScript, and we use another one called Dependabot, which is for Java. And I think Dependabot was recently acquired by GitHub. So a lot of tools available for your languages. Just try to find something for your particular case. If you don't trust vendors to do this thing for you, you can also build it yourself. It's not very hard. Relatively, just use a couple of APIs and run scripts on a regular basis. So moving on to the next thing, because it doesn't matter how secure your applications is or how much effort you put into them. These things run on infrastructure, and the good news for us is that production infrastructure has dedicated people that will try to keep it secure. The bad news, however, is that testing infrastructure doesn't have dedicated people. Most of the times, you are a small team or even a single person, and your boss comes to you and tells you, you are my best guy or girl, you are a rock star, you are the most technical person, or you are the most senior person on the team. I have a challenge for you. You will set up Jenkins and you will maintain the test infrastructure. And what you do is just download something from the internet, set it up. If it's running, don't touch it, leave it there. Your job is to write tests. Your job is to find bugs. Your job is to make sure that the product has quality. Your job is not to maintain the testing infrastructure. And the bad news is, though, that this thing can be exploited. Example number one, you may go for the cloud and just trust your cloud vendors that everything is fine. However, cloud vendors are still people, and they make a lot of mistakes themselves as well. This is an example from Atlassian.net instance from one particular company whose name I'm not going to tell you. This is their wiki page. Supposedly, this should be guarded by username and password login. It is publicly available on the internet. So you can access the entire employee directory with phones, names, pictures, and emails. You have the release schedule of their products available online. And also you have meeting minutes from the retrospective meetings, which talk about particular problems in particular teams. So you know who these people are, you know what the problems are, you know what the products are, and you can apply a little bit of social engineering if you want to. We told this company, listen guys, you have a problem, please fix it. They don't care. This is still available on the internet. Another example, again, Atlassian.net instance, different company. This time it's a Jira instance. We work for this company on a contract, and we were supposed to have access to only one of the projects in Jira. But because Jira is a very complicated software to set up, the admin said, well, listen, guys, we have no idea how to limit your access only to that project. You have access to everything. Please be careful. Like, don't delete something that you're not supposed to be. And you have interesting stuff in there. You have technical projects. You have business projects. One of the business projects talks about money, payment providers, stuff like that. Very cool information. Yeah, by the way, we still have access to that. Contract is long over. We've told them a couple of times. These guys don't care. Like, we have access to that. And like coming to the worst stuff, the actual like CI slaves, Jenkins slaves, or whatever system you're using, these things are very dangerous because by definition, they are designed to compile code to execute programs. And this can be anything. This example is from a project, I think about 1.5 years ago, that I work on. It has mixed public and private testing infrastructure. So the source code itself is on GitHub. You can find a lot of projects like that. And you see some of the public systems, you can access the logs from testing, and you can see just some internal URLs. You click on them, but they don't open. But you see that they are there, and they report pass or fail. So first thing you need to do, make sure that your configuration is set up in such a way that you allow tests to run only from people that you trust, supposedly people from your company or only people on your team, because everybody on the internet can send you a pull request. In this example, what I did is one of the developers told me, listen, we have this import program already available on the slave systems. It's installed. You don't have to compile it in the local directory. Just use it from the system-wide directory. And this is what I did. I sent my pull request. It reports pass. The first thing I did this, I forget to update the last line. So the last line initially was looking like that with the red cover. And you see it's deleting the import program. So what happens is I realize my mistake, I update my pull request, send it again, this time it fails because the import program is not there anymore. So I trust my Jenkins slave, and I realize that my tests are running with full privileges because I can delete stuff from system-wide directories. The next thing, what I could do if I was malicious, open an SSH tunnel to the Jenkins slave. From there, try to go to the Jenkins master, and I'm in the corporate network. I can do this overnight or over the weekend. My team is in the US. They will never know what happened. Like that easy, very easy to exploit. And I'm sure like you can find hundreds of projects like that on GitHub. And I have one more example a little bit later. So treat your testing infrastructure as production. And again, remember, infrastructure is software. Most of the time it's open source software. So everything that I say, all the tools that you have at your disposal, you can apply them against your infrastructure, and you open up work for yourself for the next 10 years if you don't have anything to do. And last, I want to talk about the user, because it doesn't matter what we do. The person behind the computer doesn't care about security, doesn't care about what you do. The user cares about being able to do their job, being able to solve their problems with your application. And unfortunately, system architects, designers, senior developers, they all make mistakes. Ha ha ha. So this is funny, yes. This is from Ministry of Testing, the Twitter account. However, this is in production. These guys are payment provider in the US, and 15 characters is nowhere near the length of password I am comfortable with my payment provider. So to solve this guy Justin Meyer says use multi-factor authentication everywhere because passwords are terrible. Awesome presentation. Lesson for testers here is we have the capacity to spot these bad designs, and we can participate in architecture and design meetings with the rest of our teams and tell them, listen guys, like this thing is wrong. This thing is wrong. It's not secure. It's not well designed. Let's think about some other approaches how we can design the system. This is what we can contribute back. And my last example that I told you on GitHub, we've got these guys using our software, and we find like they make their own customized version. They slapped this thing on GitHub. So they didn't change database username, they didn't password, there's no password, it's an empty password. They just updated the database host. It's an Amazon instance which is available on the internet. And we see this, like we tried to connect to their database. It took me 30 seconds to connect to their database. Everything is available for free. And we send them email, make a comment for them, no reply, they don't care. So your users don't really care about security, and most of the times they are not like well educated technically to be able to solve these problems even if you tell them what the problem is. So you need to pay attention how you design your application. This is my checklist for today. If you don't remember anything from this application, please remember this. Always inspect your application, test for security, don't trust other people, and most importantly, remember people, your customers, your users, they don't care about any of this. Like they care to make their job easier. If you can design the application in such a way that doesn't hurt them or doesn't make it harder for them to use the application, you can just impose onto them any kind of technological solution that deals with security. They will be happy about it. So thank you very much.